Welcome to this
last video of Aai Atc physics problem series, and in this video I have listed some formulas that were used to solve the physics problems in all the shifts of physics 2021 ATC paper. So let's get started. Let's look at the formulas for vectors first. So if you have two vectors a and b and the angle between them is phi, then the resultant vector has an amplitude square root of a square plus b square plus 2ab cosine of phi. Sometimes you will be given to calculate a minus b, and for that you need to use minus sign here. So one of the problems were given in shift 1 and another was given in shift 3. So this formula is quite useful, and if you have to sum more than two vectors, then please use the components, I mean the xy coordinate system, and then divide it into the components and calculate the sums. Now to determine perpendicular vector to both a and b, you can use the formula of cross product a cross b. Now the resultant vector is both perpendicular to a and b. If two vectors are perpendicular to each other, then a dot b is 0, their dot product becomes 0. And there was a question in shift 1 that if two sides of a parallelogram represents two vectors, then their dash will be representing the resultant, so that would be the diagonal. So this is basically the parallelogram rule of vector addition. Now the curl of force is 0 if the force is conservative, and in some cases your force will be given purely two-dimensional. That means it has only I and j components, and the components themselves does not contain any z in them. So in that case you can just evaluate the kth component of the curl, and that would be the curl, and the xy components will be 0. So don't waste your time calculating the other two components. And there are 2-3 questions on collinear vectors. So collinear vectors are basically the vectors that are parallel to a particular line. So the vectors can be of different magnitude or same magnitude along the same direction as well as along the opposite direction. So collinear vectors are important, I think. Now let's look at the formulas for kinematics. As I have written, most used formula for kinematics was this: S is ut plus half at square. And there are questions like if two particles are projected upwards 2 second time apart, then you need to find out where they will going to meet. So you have to use this equation very carefully. And second point says if an object falls from a height h, then it has the initial velocity u equal to square root of 2 times g times h, and you need to know the value of g in both feet per second square and the meter per second square, the common one. So for feet per second square it is 32 feet per second square. There are some problems involving feet per second square units. Relative velocity: if two objects are moving towards each other, their velocities add, and if the objects are moving away from each other, their velocities differs. And in any other case, if the velocity vectors are not collinear, then you have to add the vectors or subtract the vector in case of relative velocity using the triangular rule of vector addition. Okay, and in some of the cases it is better to use the relative acceleration formula. As I have solved a problem of shift 2, there was a mass on a truck, and that problem used that in that problem we used the method of relative acceleration, so you can revisit the formula, and it sometimes it is very useful. And the sixth point says the distance traveled in nth second is Sn is u plus a n minus 1, sorry, u plus a times n minus half. Okay, so there is a problem in shift 1 that you are given two Sn values for n1 and n2, and you need to find u and a. So this problem is used for once in shift 1. Now laws of motion. So in case of tension on a string or pulley, mass pulley system, or any other system, you need to draw the free body diagram properly, and in some cases the formula for centrifugal force is used. So depending on whether you need the frequency or you need the velocity, use the relevant terms directly to get that. And there are few problems, I mean 2 to 3 problems involving centrifugal force in each paper, so be a little careful. And there are banking problems also. For banking problems you need to draw the free body diagram very carefully, and then uh, if the banking angle is phi, then this angle is phi and this angle is also phi, so you need to write the angles very carefully, and the friction is mu times this normal force. Okay, but that normal force will have a component mg cosine theta and mv square r sine theta, so be careful with the components. Now optics problems are very important, because in each of the shifts I have seen that 2 to 3 problems are from optics. And first formula is the Lens-Maker's equation, which is 1 by f is mu minus 1, refractive index of the material of the lens, minus 1 into 1 by r1 minus 1 by r2. So for biconvex lens, r1 is positive, r2 is negative. And by the way, this power of a lens is basically 1 by f. So remember this if they ask you to calculate some power or something. So this is quite useful formula actually. And the equation for lens is 1 by f is equal to 1 by v minus 1 by u. V is the image distance, u is the object distance, and in case of lens, the magnification formula is v by u. And similarly, equation for convex or concave mirror is this 1 by v is, sorry, 1 by f is 1 by u plus 1 by v, and f is r by 2, basically the radius of curvature. And this radius of curvature for concave mirror is negative and convex mirror is positive, and for the case of mirror the magnification is minus v by u. Similarly, the equation for spherical refracting surface, there was one problem where the equation is mu 2 by v minus mu 1 by u. This is the refractive index of the spherical surface, and this is the medium from which the light is coming, and this r is the radius curvature of the refracting surface. And the critical angle, for the critical angle, sine of theta c is 1 by n. N is the refractive index of the medium for which we are calculating the critical angle. So if light comes from air, I mean this critical angle is for air and that particular medium. So this was also useful in one problem, as I can remember. And there are two problems on this formula, that is the refractive index of prism divided by the refractive index of the surroundings is sine delta plus a by 2 and sine a divided by sine a by 2, where delta is minimum deviation, a is the angle of prism, and I forgot to write another formula here, that delta plus a by 2 is basically the angle of incidence for minimum deviation, that is I. So this formula is also very useful, and there are two problems in shift 3. uh, General properties of matter. The most used formula for general properties of matter was Bernoulli's equation. So P1 plus half rho V1 square plus rho GH1 equal to P2 plus half rho V2 square plus rho GH2. In some cases will be given that they are horizontal, so these terms are not they are not exist, so you have to do with these two terms, and this was very common problem in all the shifts. And in one shift I can remember there was a piston problem in which you have to use the Pascal's law also, so this formula is quite useful. And there was one problem for spherical soap bubble, which was a quite lengthy problem. And for spherical soap bubble, the internal pressure minus the outside pressure is 4 times the surface density divided by the radius of the bubble. The next thing is the capillary rise. The capillary rise H is equal to 2 times the surface tension divided by the density of the liquid into G times R. And one problem was given in shift 3, in which there are two capillaries of radius R1 and R2, and it was given that for the capillary with radius R1 the height is H1, and you need to find out the height for the radius for the capillary having radius R2. So basically you have to use the formula H is proportional to 1 by R. And then there was another question that requires the formula that Reynolds number is equal to the rho times the velocity times the diameter. Remember, this is diameter, not the radius, divided by the viscosity. And for streamline flow, this Reynolds number is 2000. The maximum possible value of Reynolds number is 2000. Okay. The viscous flow for a liquid is eta times A times this velocity gradient. That means the velocity of the top layer divided by the distance of the top layer from the bottom layer. Okay, and the problem said the force, the area, and the gradient, and you need to find the eta. Okay, be careful about the units here. Alright, so heat is also important, and the most used equation is the heat transfer equation, that is the rate of change of heat that is uh, going out of the system or coming to system is equal to the thermal conductivity into the temperature difference times area divided by the thickness x. Okay, and the second most used formula is the heat exchanged for a material with mass given, specific heat given, and the temperature difference given is Q is ms delta T. And remember, in these problems there are some kind of phase transitions involved, that is ice is melting to water and then increase the temperature of water, and then the water turns into vapor, and then there is an increase in temperature of vapor. So in each case of phase transition, like 0 degree water to 0 degree ice, you have to use the latent use of fusion, and 0 degree sorry, 100 degree water to 100 degree vapor, you have to use the latent heat of vaporization. So be careful about that. And very cautious, you should be very cautious about the units of specific heat, because most of the times it was given in joule per gram per Kelvin. So do not use kg, use grams. And be very careful because the other units are in SI, and the only CGS unit used is grams. And the last formula is the Newton's law of cooling. There was one problem in shift 1, and the formula says if a material is cooled from T1 to T2 in time T1 to T2 in time T, which is equal to K times T1 plus T2 divided by 2 minus T surroundings. So the problem said that there were one material and it first cools from T1 to T2 in the time was given, the surrounding temperature given, and then from that given information you need to find K. And then the question says that what would be the time of cooling when the material is cooled from T1 prime to T2 prime. So basically you have to use the K in this equation and find the value of T. There was only one problem for Newton's law of cooling in 2021 paper. Okay, so electrodynamics consists of a large number of problems, and the energy stored per unit volume in electric field is half epsilon naught E square. And second is the cyclotron frequency nu is Q times B divided by 2 pi into the mass of the charge that is rotating. So there are two problems in shift 3 regarding cyclotron frequencies, and from frequency sometimes you need to calculate the time period also, which is 1 by nu. And there are one problem about the intensity. So that is, a light bulb has a power of say 10 watt, and what is the intensity at a distance r each say 5 meter. So how to do that? So intensity is basically power divided by the area of sphere, which has a radius from the source to the point considered. So basically in this case, just as I mentioned, if the power is 10 watt divided by 4 pi into 5 square. So basically intensity is power divided by, power per unit area. Okay. And then the famous Gauss law, square integral of surface integral of E dot ds is Q enclosed by epsilon naught. The electric field above and below a charge plate is E above by minus E below is sigma by epsilon naught. There is one problem in shift 1 in which this and this were given. You need to find out sigma. So only one problem. And displacement current is basically epsilon times the area times dE dt, which is epsilon times area into E is V by L and T. So you will be given, there is a capacitor and the area of the capacitor will be given. Okay, and you need to find out dE dt. In some cases the AC RMS voltage will be given. So there will be a term of frequency coming out in dE dt term. So be very careful. This was in shift 2 as I can remember, and shift 1 as well. Two problems. So a typical equation for electromagnetic wave is E0 into cosine k times r, k dot r minus omega t. K is the wave number, which is 2 pi by lambda, and omega is the angular frequency, 2 pi f. and for electromagnetic wave, E0 by B0 is speed of light in that particular medium. There were 3 to 4 problems from this formula. In shift 3 there was 2 problems. One the B0 was given, we need to calculate E0, and in another E0 was given, you need to calculate B0 along with the value of lambda and F. So in this case I want to mention that for the electric and the magnetic field, the wavelength and the frequency are the same. They do not have different values for electric and magnetic field. They are of same values. And there was one problem about the potential energy of an electric dipole in an electric field, which is U is minus P dot E, which is minus PE cosine theta. So you have to think what is the initial potential energy and what is the final potential energy, and for work done you have to calculate final potential energy minus the initial potential energy. Torque on a magnetic dipole in a magnetic field is tau vector is equal to the magnetic dipole moment cross the magnetic field, or in magnitudes mb sine theta, and m is in generally current times area times number of turns. There was one problem in shift 3 which uses this formula. Now these are some list of formulas. Electric potential inside a sphere at a distance r of a charge q is kq by 2r 3 minus r square by capital R square, where r is the radius of the sphere and r is the distance from the center that is considered. K is 1 by 4 pi epsilon naught. Magnetic field due to infinite current wire is mu0 I by 2 pi r. This formula used in two problems in shift 1. Magnetic field due to circular ring is mu0 I by 2 r. Magnetic field inside a solenoid mu0 Ni by L. L is the length of the solenoid and N is the number of turns, I current, and outside of solenoid the magnetic field is 0. Magnetic field outside, this is a typing mistake. This is outside a toroid B is mu0 Ni divided by 2 pi into r1 plus r2 by 2, where r1 is the inner radius, r2 is the outer radius. There was one problem in shift 3, and magnetic field outside the toroid is 0. This is toroid, and the magnetic energy per unit volume is 1 by 2 mu 0 into b square, and this is same as half epsilon 0 e square for electromagnetic waves. There is a problem of galvanometer in shift 1 and another one in shift 2. So to make a galvanometer and ammeter, a small resistance R is connected in parallel, and the resistance R that is needed to make it an ammeter is basically the maximum current that can flow through the galvanometer times the resistance of the galvanometer divided by the current that we want to measure, I, minus the maximum current through the galvanometer. This Ig can also be thought of the maximum current needed to fully deflect the galvanometer. And to make a voltmeter, you have to use a large resistance R which is connected in series with the galvanometer, and the resistance is V minus I times Rg divided by I, where V is the maximum voltage we want to measure and I is the maximum current the galvanometer can afford. and Rg is the resistance of galvanometer. So these formulas are quite important as well. Now there are two logic gates that are used in every problem consisting of logic gates. One is the NOR gate, which looks like this, and the output is A or B and the NOT of whole thing. So NOR gate is consisting of one OR gate and a NOR gate, and NAND gate is looks like this, and the result is A and B and NOT of the whole thing. So NAND gate consists of an AND gate and a NOT gate. And the most important theorem is the De Morgan's theorem here, which says that A and B bar is A bar or B bar, and A or B whole bar is A bar and B bar. Few tips that you all know, but let me speak out. So be very careful about the units. Sometimes you need to multiply pressure times area, and the area was given in centimeter square and the pressure was given in Pascal, so you need to multiply 10 to the power minus 4 factor. So you need to be very careful about the units, and of course the less you use the calculator, the more time you gain. So you can use the legitimate approximations like G is 10 meter per second square by is 3, and electron has a charge of 1.5 into 10 to the power minus 19 coulomb to save some time. And if the options are different to a large extent, then you can use more approximate values. Next thing is that look at the options first and try to see which is the probable one, and sometimes you need to carry out 2-3 values for a given problem and try to find out the value for which the options are the most different. And finally, start with a problem that you can surely do. It will give you confidence, and confidence matters in any exam. And finally, avoid too big problems because it will cost much more time, and in that time you can do 2-3 more problems. So that's all the very best for your exam. I hope you will achieve your target. So if this video was helpful or the series was helpful to you, please like, share and subscribe the channel. Finally, thank you, and again all the very best.